I guess I'll begin then, and if anyone turns up, there's still quite a few. There's 3 places at the front here, but there's quite a few gaps. Thank you very much for being here and for listening to this talk. I guess most of you will have some context on Pydantic, on who we are, and on what we're building. But I think that the biggest question people will have is, why Logfire? Why would some people who are known for doing known for doing data validation, go and build an observability platform? Sure, it has an integration with Pydantic, but still, it seems a little bit departed from what we've done before. And I think that's the main question I'm going to try and answer today, and partly because it's what I'm trying to do, but also partly as I think it answers that question, to try and persuade you to go and try Logfire and hopefully get the same experience we've had and realize why it's so useful. So, as you know, we maintain the Pydantic data validation library, and I, for one, have spent a lot of the last 5 years of my life building Python libraries. Building libraries is an incredibly nice experience as a developer. You don't have to deal with networking, you don't have to deal with any sort of state within your application, it's just your library. In the case of libraries like Pydantic, it doesn't even need to do any networking. So you have an incredibly simple and constrained situation in which to go and, sure, implement complex things. When it comes to building applications, a whole range of different concerns come in and make software development more complicated and often less fun as well. So you have networks, you have databases, you have APIs to all sorts of different things of all sorts of different kinds. You have infrastructure. Almost worse, you have the abstractions on top of infrastructure that seem to be designed to make it yet more complicated and prove the value in the people who know how it works. And then worst of all, you have users who complain and do weird things and don't explain to you what it was they did to manage to produce an error. And I thought for a long time, I think I first bought the Logfire domain name back in 2017 or 2018, that the problem, the big missing piece for me when building applications was logging, or not quite logging, but something like logging, but that gave me more context and let me understand better what was going on inside my app. It was kind of driven by this, I love Sentry, Sentry's great, but Sentry wasn't doing quite all the things I wanted. I wanted to go and use it for application level stuff. I wanted to use it to understand how users were interacting and how my application was running, not just for looking for errors. So what's a log? A log is really a 1D list of things. At the minimum, it's one thing, just a message. So if you think about print, that's all it is. When you come to deploying applications, you generally get at least a timestamp on top of that. And then very often you get a level. Sometimes that level is binary, standard out or standard error. Sometimes that level is whatever, info, notice, error, warning, whatever. But it's a really very, very simple event log of what's happened. And the problem is that it's very hard to piece together when you have multiple different people interacting with your application, which logs relate to which events. So if we look at this list here, we have some GET requests. Sure, they responded with 200, everything is good, but we have no idea how long they took. We could start adding timing into the log, but that gets more complicated. But then the third one down, we have this Stripe payment failure. Okay, and then we have 2 different responses that came back in around the same time of 400. Which one is that payment failure related to? There is fundamentally no way of finding out without going off and looking into individual users' accounts and what payment events have happened. And then we have this debug query, which is perhaps the most interesting of all, but generally would be labeled as debug, and you wouldn't probably even see it in production, which is saying there was some slow query. But you probably don't get the whole of the select, because if you put the whole of the select, it's going to wrap and it's going to get impossible to read. So all I'm trying to persuade you here is that there's a better thing than logging to understand your application. And I think it's also worth noting that this is what software looked like until about the 70s. There were basically linear lists of commands, and then someone came along in Fortran 77 and started putting in sub-procedures, basically functions. And it was really helpful once you were able to contextualize different blocks of logic into units you could think about. But we've moved on from there, and we have some even more sophisticated abstractions that make it even easier to write code. And yet our logging still has fundamentally the same structure as those original lists of commands in PL5 or whatever. So this is how I think logging should be at an abstract level. I've use Python syntax to describe it, but that doesn't really matter. The point is that we have in our log, we have a start timestamp, like we had that before. Critically, we have an end, which tells us how long it's taken. We have the message again, same. We also probably have level, which I've omitted here. Then we have attributes where we can go off and store any other data we want. So that might be, for example, a full SQL query without showing it to someone the whole time. It might be information about a Pydantic validation and why it succeeded, in the data when it succeeded, or the reasons why it failed. But most importantly of all, and this is where it critically changes, we can have children for that log. So another list of logs within that log, which then in turn they can also have children. And so now we have, instead of this linear sequence of events, we have a tree structure which allows us to understand what's going on almost immediately. So if we take some of that previous example I gave you and we write it out again with kind of Python code describing what was going on, we see our top level log, we're just showing one here, is that HTTP request that returned 400 from the payments endpoint. But within it, we have another log, which is the Stripe payment failed. We have immediately solved the biggest problem with logging, that we don't know what's associated with it. And we've done it in such a simple way that if someone started off by looking at this, they wouldn't even consider that the previous error could have happened. And I think it's worth saying to a bunch of you will have used tools like Datadog and will be sitting here going, but that's been solved. He's talking about old news. And I agree, there have been things that solve this around for a long time. But I still see Python developers, and not just Python developers, all sorts of developers, managing basically or failing to solve problems because they are still using an old-fashioned linear log. And so that's why we've gone off and built Logfire. So this is perhaps quite a lot of code here. It might not be that readable at the back. There'll be more examples later. But we basically take that same endpoint where we had that payment failure, and we add a few lines of code here. In particular, on line 4, we add logfire.spam, which is a context manager, and we put that around the Stripe request to basically give us a log, or what I'm calling a log here, which is really a trace, which is giving us the start timestamp, the end timestamp, and allowing us to nest more logs within it. And by doing this, we are able to affect, and I'll say also on line 14, 15, we add some more details there. So on particularly on line 15, we add, as an attribute, more information about the error, and on line 17, we add more attributes, which is the payment intent in the event that the payment succeeded. What this gives us is this, and I don't know how easy that is to view, but this is a screen from Logfire. This took me a few minutes to set up, like one line of code or 3 lines of code added, and we immediately get that tree structure. It's not that noticeable here because we only have one level of nesting, but you'll see later we have more levels of nesting. But we have 2 payments going on. The first one you see succeeds, and on the highlighted line, here, we're selecting that. So we see on the right the arguments, which is in fact the attributes that I was showing you adding earlier. And then the next request below fails. You see it's highlighted in orange, and we immediately get that tree structure. So I'll go on to show lots more examples, but that begins to introduce, I hope, the principle of what we're trying to do in Logfire. Again, lots of you will be feeling, come on, this isn't new. These things have existed for a long time. I think there are a number of things that we're doing with Logfire that are completely new. So OpenTelemetry is an open standard for observability developed by Splunk and Datadog and Microsoft and lots of other large companies. It's a very powerful way of doing observability in a non-vendor specific way. They have, as I'll show later, integrations with lots of libraries already. The problem is it is a pig to use. And that's not the fault of the people who built OpenTelemetry. They made a decision early on that they would have the same API for all programming languages, which, as you can imagine, basically means you have to use the kind of lowest common denominator in each place, and they have enormous amounts of control you can set up, and you will end up writing somewhere between 10 and 50 lines of code to configure OpenTelemetry once you've understand all of the concepts. Logfire is built on top of OpenTelemetry, but we abstract away the complexity of setting it up and let you get going in an import on one line of code. Secondly, we're Python developers. We care a lot about the experience for Python developers. And so we've done a bunch of things that are kind of magic in Python that should make your life easier, that other observability companies aren't doing. So we have what we call auto tracing, which is effectively inserting spans around every function. So you can see which bits of your code are fast and slow without having to go and write those manual logfire.span lines. We have fstring magic, which I'll come back to in a minute, which is effectively extracting attributes from fstrings, so you don't have to write them all out manually. We have some tools for generative AI that allow you to see in detail what's going on when you make calls to those APIs. We may have varying levels of cynicism about generative AI and where it might go, but it's definitely going to be relevant to lots of us, and being able to get first-class support within a general purpose observability platform without having to go off and use something which is specifically for generative AI is super useful. And lastly, we let you query all this data with SQL, so you don't have to go off and learn some new query language. And one of the other advantages is ChatGPT is really good at writing SQL, even if you don't want to. But most of all, it is easy to use. Easy to use in terms of lines of code, easy to use in terms of amount of brain power required to do it. Because most people are not observability experts. They don't give a flying fuck about the difference between a trace provider and a trace, and they just want to get on with their thing. And that is what Logfire tries to abstract away, so you don't need to worry about it. So I guess that kind of brings me on to the high-level point here. We are not observability professionals. We are not, unlike most observability companies, we haven't spent the last 15 years of our life inside Meta or Datadog or Microsoft doing observability at enormous scale. Instead, we are Python developers who want to consume it and have strong opinions about how it should be. And I think that makes us really good people to go and build something like this. But it does also mean that we'll make mistakes. I mean, they make different mistakes, so I wouldn't worry. But I would love all of your feedback as much as possible. If you try Logfire, that is what's going to make it great, not our basically v0.1 that we have now available for you to try. So join us at our booth, join us on Slack, report stuff on GitHub. We won't complain. That's not a bug. It's a user mistake. If it's a user mistake, it's our fault, and we will go and fix it. So enough of that. Let's give you some examples of what Logfire can do. So this is the very simple, I guess the kind of hello world example. Well, literally the hello world example. So in most of these scripts, you'll see, oh, that's decided not to work. Okay, well, I'll have to talk through it without lines being highlighted. But we have import Logfire and then Logfire configure. As you can imagine, you can pass a bunch of arguments to set up Logfire there. Most of them are all obviously optional. So provided you've got an API key set, that's enough to start sending stuff to Logfire. Then we have the very simple, the obvious way of doing it, which is that we have a template string with a positional variable in it, and then we pass the variable in. That will get obviously rendered as hello world, but we'll also collect the attribute, which in this case is kind of boring, but will be much more interesting if it was some, say, large Pydantic model or data frame that you wanted to be able to see inside the Logfire UI. Then we have a span, as I said before, which gives this idea of giving context. There are some seats if you want to come in. There's some down here and there's some in the middle, if you want. And then within that span, we have logs, which obviously, when you view them, will be nested within that span. And then we have a sleep here, because there are three valuable things that spans give us. They give us the duration that the thing goes on for. They give us the context that I've kind of shown here. And lastly, they collect any exceptions that go on within them. So they don't catch that exception. It will go on up the stack, but you will be able to see it in the UI. And then we have another span, and obviously you can nest spans as much as you want. You probably don't want to nest them infinitely, but up to kind of 5-10 levels of nesting works reasonably well. And then we have a warning, which is, again, very much like info, but just communicates a different thing. And what's really neat is that we can switch all of those to F strings. We get, as you will see, it gets much less verbose. We get autocomplete from IDEs, and we get errors from IDEs if you use variable names that don't exist. But we have the magic that basically goes in and extracts the template name and extracts the attributes, so it renders exactly the same as it would before. So what does that look like? We see here, it's obviously not a particularly exciting case, but we see all of the stuff we talked about here. You see that even though we use the F string, we have the attribute pulled out on the right, Again, these attributes aren't very interesting yet. I'll get to them in a minute. But you start to see the nesting that goes on. And obviously here, these traces are open, but one of the really useful things is that you can have them closed when you're not looking at it, and you don't get too much stuff deluging your screen and making it hard to find the thing you're looking for. You also start to see the idea that spans can be built up to form a trace and give you an understanding of what within your application is happening quickly and where the slowdowns are coming from. That is being really annoying. Auto tracing, as I said before, super valuable tool where we can effectively wrap every function call in a span without you having to go in and instrument them manually. So this is a script I have for going and scraping GitHub for all the dependents of Pydantic. And you'll see here that we have each HTTP request, but we have a surprisingly big gap between it. So what's going on in that time this instrumentation here is coming from the HTTPX instrumentation, which I'll come to later, which effectively allows us to collect the duration and result of HTTP requests without writing any code, but we still have this kind of gap between each one. What's going on? Well, if we add auto tracing, we start seeing which functions are taking what amount of time. We see beautiful soup taking up a little bit of time doing the HTML scraping, and actually when I dug into this, slightly embarrassingly, I had a sleep of 1 second between each call to avoid 429 from GitHub, which was the reason that it was being slow. But using auto tracing was able to help me on that trivial case, but in big code bases where it's not feasible to go and instrument everything, it can be super useful to get you going and start finding out where slowdown is coming from. Next, we have pretty Python objects. So here we have a Pydantic model that we're going to log with logfire. Most of the attributes I've shown you till now have just been simple strings, but if you were to log something like a Pydantic model or a list of Pydantic models in logfire, you get a view like this. So there's a number of things here. One, they're collapsible, like you would see in an IDE. Two, it's not just JSON. We have information like it's showing as a delivery. That might seem like it's just pretty, but obviously knowing what Pydantic model it was or what data class or what attribute class was your printing is incredibly valuable in when you're showing it. This you don't get at all from standard OpenTelemetry. OpenTelemetry has basically support for simple types like lists and integers and lists of constant types. So there is no way that you could send this stuff through OpenTelemetry vanilla. What we do is we send the JSON, and we also send a kind of hybrid version of JSON schema, which gives the extra information about things like that it's a Pydantic model and what the model name is that allows us to render this. So gives you an enormous win over OpenTelemetry, again, for no work from you. It was just simply, we had the number of deliveries that we put it in the message itself, and then we added deliveries as another attribute. And the point is here, although that attribute isn't rendered in the message, it's still sent, and you can still go and see that data. How am I getting on for time? Next one, databases. Databases are obviously key part of any real application development. And this is one of the big wins we get from being built on top of OpenTelemetry. We don't need to go and write the code to allow you to automatically instrument lots of different databases. I think we've listed 9 databases that are already supported by OpenTelemetry. There are 2 or 3 more that are already available. And as more come online, they'll just work with logfire. So we have a specific logfire command for async PG, which is just logfire instrument async PG. But if you're using the other ones where we don't have a particular command, any OpenTelemetry integration, whether it be one of the open source ones or some proprietary one, will just work with logfire. You'll send, the data will come through. We'll be able to render it, in most cases, in a pretty way. Sometimes not in such a pretty way, but in general, it'll be pretty good. And then you see in the screenshot, we have an HTTP request here to API table. And then you see we have a number of different queries. This first one is what we're showing, is what is selected, so is what's showing on the right. And we see the SQL here. Pretty simple query in this case. And sure enough, it only took 2 milliseconds. And then account, again, took a similarly short period of time. And then async PG does this unlocking stuff on every query. I didn't even know that until I instrumented async PG with Logfire and saw these queries going on every time I took out a connection. This example is obviously a toy app I've built to show off Logfire, and all of the queries are pretty fast, and there are 3 or 4 of them, and you could question how useful it was in this particular case where the whole request took 10 milliseconds. But if I show you a real-world example, I'm sure you can't see all of this at the back, but I'll share the slides afterwards. This is use of Logfire in a real-world application in a real company and this wasn't us kind of setting up this case to show how useful Logfire can be. You see we have, I don't know, 10, 15 different database queries going on. Most of them are taking 1, 10, 30 milliseconds. And then we have this one case here, which took 1 second. And that's why the top level HTTP request is taking 1.5 seconds. As a user, trying to read the code and understand what was slow, it's going to take you hours to find this. This is a Django application, so you don't even get the SQL to read. You have to go and infer what the SQL might be from the ORM, or you might be able to use like Django debug toolbar in local development, but then you're not going to have enough data, and then you find yourself downloading a production database to log in as some user having reset their password to try and recreate the situation. I've been there. It's not pretty, but it's the only way you can do it. With Logfire, you immediately see, this one request didn't take 46 milliseconds, it took 1 second. And we can see the SQL here. And we'll soon have integrations so that we basically get auto-explain in Postgres in particular. So you'll be able to see the explain rendered in the right-hand panel in a pretty way, and you'll be able to work out even more quickly why this particular query was slow. Because sure, it's Django, and so the SQL it writes is super verbose, and you can see some like 500-line SQL. But the query above that took 1 millisecond is also some enormously long piece of SQL. It is not at all trivial to work out from just reading the code what would have gone wrong here. But Logfire immediately allows you to look at it, not even think about having to calculate which one is slow. You just look at the page and you're like, here's what the problem was. So next, web frameworks. I've already kind of given you a few examples of integrations. Previous one was Django. I've also had a fast API example. This is a fast API example as well. But again, because we're built on top of OpenTelemetry, there's existing integrations with a whole bunch of web frameworks you might want to use, and some you definitely won't want to use, but they're done anyway. And again, we obviously have particular support for fast API, which we're very close to, so it's as simple as logfire.instrument fast API with the app, and you get a bunch of useful stuff. We actually do some stuff on top of OpenTelemetry in the case of fast API that I have rather stupidly neglected to show here. So we'll show you the arguments being passed to the view function effectively on fast API, which can be really useful. And then you can also get from OpenTelemetry all of the headers that are being sent and the query parameters. Again, tools before have offered you this in the particular case of errors, but in general they don't give it to you in the case of requests that are fine or requests that are slow but didn't happen to come up as an error. And again, you see immediately the durations of everything down the right-hand side. The timings here are a bit weird. They're done on a logarithmic scale, which can be very confusing to read, but the problem is when you have one request that takes 30 seconds, it just then means everything else is basically looks instant. So logarithmic scale for that right-hand for the durations is helpful. It's not always perfect, we may end up making a switch, but yeah, that's why we've done it that way. HTTP requests, so where web frameworks were basically instrumenting incoming HTTP, we can also instrument outgoing HTTP requests, the support for the main 3 libraries. In this particular case, before I come on to this particular case, because it's relevant to the next slide, one of the things that this will obviously collect the outgoing request URL, the response code, but it will also insert another header, which effectively sets the trace ID for OpenTelemetry, which enables auto-tracing to work. So I'll show you what that means in a minute, but it's doing more in this particular case than just observing. It's actually adding a header to the request. So this is the same example I had before with Stripe, but instead of inserting my logfire.span manually and collecting the attributes, all I've done up here on line 1 and 2 is I've imported the requests OpenTelemetry library and basically turned it on. So again, this is not a library where we have a logfire.instrument requests method yet. I guess we will, but this is a demonstration that it will just work even though we don't have any code specifically for requests within logfire. And again, there's no code specifically for logfire within Stripe. We have no Stripe integration yet. I think we will probably do one, but you get a pretty good view of what's going on within those same payments when they succeed and fail just from enabling the requests instrumentation. So you see here we have 2 payments again within 2 HTTP requests. The first one passes and is, I'm colorblind, but whatever that color is, and then that one is a different color. I don't know which one's which. I mean, I can see that one is reddish and has failed, and you'll see that there's the error code from OpenTelemetry is error, which we slightly misleadingly describe as exception here. That will change fairly soon. But you can immediately see where payments are failing, and in particular how long they're taking, right? Because these Stripe requests, because they have to hit the merchant acquirer bank, are taking 1.2 seconds. It wouldn't necessarily be entirely obvious to someone who hadn't spent years working with Stripe that those requests are going to be particularly slow. And so you will be looking at your logs saying which of the queries in this endpoint is being slow. These the Stripe requests when you're using a testing key are much faster because they don't actually go and hit the merchant acquirer. So again, you wouldn't see it immediately in development. You put it into production, wonder why these endpoints are slow. Logfire would tell you kind of instantly. Distributed tracing. So I just kind of touched on this point, but with your web framework instrumented and with your HTTP library instrumented, you can immediately effectively get what's called distributed tracing, but effectively spans that transcend different services. So you'll see, unfortunately, the colors are almost identical down the left-hand side here, but these requests are to a service called Web UI, which is one Docker container, and then at some point here, we transition into a different service called tiling. So this particular this particular service is rendering a map where we go off and have a separate service which gets different images from OpenStreetMaps, tiles them together, but the request is going through the web UI, and so we get one unified trace showing you what's going on. There's another example that I'll come to later, which is clearer, if only because the random logic which generates a color for our services is better in that case than in this one. In fact, that's this next case here. So this is support for other languages. Another big win we get for OpenTelemetry is that although the SDK we have built is specifically for Python, and things like the pretty way that we display attributes has specific logic for Python, because it's OpenTelemetry and most languages are supported, you can go and build, instrument your application in any language with OpenTelemetry. You get a pretty shitty experience of having to set it up because you have to go and configure the trace provider and the trace exporter and the batch spam producer in Logfire, but that's what all the other observability companies are telling you to do anyway. So you move down from the Logfire kind of level of user experience to the honeycomb level of experience, but you can still send your data to Logfire and you don't get the pretty display of attributes necessarily, but you can still see what's going on. So this is a React app, and we've basically set up OpenTelemetry in the front end to send the data to Logfire, and again, also to apply the OpenTelemetry header so that we get the distributed tracing. And then we also have a Go app in this particular case. So this Go app is doing nothing, hence why you'll see in a minute the request is very quick. But again, you can see that we've added middleware to apply OpenTelemetry. And with those two instrumented and a Python app in between that I haven't bothered to show in this case, you'll see that our trace goes, it's not very easy to see, browser, first of all, so where the request first comes from, then through the service that's written in Python, and then into the Go service, and you'll see the response time for the Go service was 0 milliseconds, because I think it was just returning the user's user ID. So we're not claiming yet that we have the same kind of level of user experience in other languages that we do in Python. I think we do plan in the medium term to build, again, opinionated, nice, easy to use SDKs for at least JavaScript, TypeScript, and Rust. We probably won't go and do all languages, but I think those, because that's what we're building in and that's what we want. But in virtually every language you've heard of, you can use logfire today, just using standard OpenTelemetry instrumentation. One of the kind of most obvious integrations that I should perhaps in some ways have put earlier in the talk is with Pydantic. The idea is that we add this one line here, line 5, which effectively turns on the Pydantic instrumentation for all Pydantic models. You can also do it on a per model basis. And you can also decide what's recorded. So you can record all, which basically puts a span around every Pydantic validation and will show you when things fail and when they succeed. Or you can have fail only, or you can record only metrics. So in observability terms, today we've talked almost exclusively about traces. We've talked about traces as a kind of substitute for logs. But the third pillar of observability is metrics, which is, I guess you all have a kind of feeling for what that means, but it's basically numeric values. Logfire can also record metrics. They're not as pretty in our UI yet as they will be, but they allow you to do a bunch of stuff, in particular where you have very high volume and you don't want to send spans for every single request or every single Pydantic model that's being validated. You can send through metrics, and therefore you could have a graph perhaps of percentage validation fails that might give you an indicator when something went wrong without having to send all the data every time. Other than that, this example is basically the same as before, except we've got rid of the logfire.info at the bottom, and instead we've got some invalid data that we're going to try and validate to show you what an error looks like. So this is what you get. You'll see we have those 3 successful validations going on. They're all pretty quick. They all show us 1 millisecond in this case. And you see in the attributes, we have lots of useful data. So we have the result. So effectively, the Pydantic model we got out of doing validation. We also, the success was true, which would be useful if you were trying to filter this data. The input data, which is obviously very useful if something went wrong to understand what that was. Name of the schema and the validation method. In this case, we were validating with JSON. And then in this case, the last one that failed, you'll see the dot errors method output from Pydantic, which tells you the reasons why the validation failed. So I think this is going to be super useful within big applications or big systems that use a lot of Pydantic, where critical data is running through Pydantic, and effectively you can get a view into both what's succeeding and what's failing without having to write any code, effectively within that logic. Another perhaps obvious thing we have to talk about is LLMs and generative AI. We have a specific instrumentation for OpenAI. And there are a bunch of community-maintained ones for things like Anthropic. I don't know the quality of them yet. We'll probably build more if people particularly want them, but I think a lot of people developing with generative AI right now via an API are using OpenAI, and we have I think a really good instrumentation. We're aided by the fact that, well, both OpenAI and Anthropic use Pydantic extensively in their SDKs, but actually most of this instrumentation is it's effectively a level on top of the HTTPX instrumentation. So in this particular case, what we're doing is we're wrapping everything we're doing in a span so we can see how long it took. Then we're asking OpenAI for the most influential painter of the 20th century, and then we're asking their image generation DALL-E 3 model to generate a picture of a cat in the style of whatever we got back from the first one. And again, we haven't had to manually instrument any of those calls. All we have is that top level logfire span that says we're going to go off and do this task. And we immediately get back lots of details. So in particular, in the right-hand panel, it's shown underneath here, we don't just get that like kind of JSON view or pretty JSON view of attributes. We get a right-hand panel that hopefully gives us a better view into the particular exchange that went on with the LLM. So in this case, it decided Picasso was the person, and then it went off and gave us a picture of a cat in the style of Picasso. Slightly amusingly, the first time I called it, it replied saying that Jackson Pollock was one of the influential artists of the 20th century. Then when it submitted Jackson Pollock to the image generation, it returned saying that was like outside their community guidelines. I think because Pollock sounded like bollock. I don't know why, but we can guess. But yeah, the first time I did it, we got back an error. And you can see, luckily, this is a nice way of viewing the exception, the traceback view in Logfire. We see the traceback, where it happened, and the message here, why it didn't like that particular input. And again, you see within this top-level trace, we see the two spans, and we see their relative durations. In this case, they both seem to take about the same amount of time. In the previous case, you see that the call to GPT-4 to work out who the painter was much, much faster than generating the image. So the panel I showed here with the cat is obviously a kind of custom component that isn't what we normally show in the right-hand panel, where we show the kind of pretty JSON. But the way that we've built that is with effectively what we're calling custom panels, which is effectively a way of building UIs within Logfire, and therefore allowing you and us to take it to the next level without basically constraining it to a fixed set of different components. And in fact, that's partially built on, or definitely will be built on, FastUI, the UI generation library that we released earlier this year. So this is, in fact, effectively the code editor where we were working on building the LLM output. And you can see effectively that we're writing TypeScript, and it's full TypeScript with types and errors when it's wrong, allowing you to configure what you put in that right-hand panel. And again, in this case, it's an exchange with an LLM, but in theory, it could be anything you like. It could be a panel that shows you details about one of your users. It could be a summary of what to do next for your customer service person if you wanted to give them access to Logfire. I was very strongly of the opinion that Logfire shouldn't just be for developers, but that it should allow you to go the next stage and go and use it to understand your application or even your business, not just your code. And I think that the custom UI will be a really important part in allowing people to do that, as well as kind of ticking the LLM checkbox. And so on that same point of allowing you to basically do whatever you like with this data, we allow you to write SQL to query your data directly. So even in very sophisticated, probably, Datadog, which is kind of the big incumbent in observability, it's not trivial to go and write queries like this, because they're not letting you write SQL, and they have something almost akin to a query language, but it's obviously not as sophisticated as full SQL. So in this particular case, using the same example we had before with the artists and the picture, the first query here, we're basically getting 3 columns. You see attributes that I talked about earlier as JSON. So we're using Postgres's syntax for getting different keys within the JSON, and we're getting the number of tokens used. That's the cost, basically, from OpenAI of doing those particular requests. And we're also showing the message that got back, and you'll see that's the table here, timestamp, number of tokens it cost us to make those requests, and the message that we got back. And you'll see this one goes off screen, but it has a lot more content, and that's where it said Jackson Pollock. And then we can also go and run an aggregation, because it's just SQL. So in this case, instead of getting multiple columns, we're just summing the total number of tokens. So you can imagine what I haven't shown here is dashboards, which basically let you take the SQL and build charts or components you like to basically monitor your application at the next level up. So we have effectively the live view, which is where I spent most of today showing you how Logfire works. We have the SQL editor, what we call Explore view. We have dashboards, which I'm not showing you today. Their honest truth is they're not perfect yet. They need a lot of work. And then we have alerts, which effectively, again, let you write SQL to alert yourself when things go wrong. And again, the idea is that because it's SQL, you can do effectively arbitrarily complex things to work out when an alert needs to be triggered and when it doesn't, which aren't possible within other applications where you're not being allowed to write SQL. So that's kind of all I've got for today. We're going to have lots of time for questions, but most importantly of all, we're here all week. We would love you to try Logfire and tell us what you think. Come and talk to us if you have any trouble. Come and talk to us if you want help instrumenting an app or a particular library you want instrumentation for, or any issues you run into. We would love to hear from you. And after PyCon, please join Slack and again, ask away whatever you like. And I'm not saying we don't have a threshold for being annoyed by dumb questions, but we haven't hit it yet. And also, if you have any questions on Pydantic, join Slack again and ask again on there, and we'll probably answer Pydantic questions. We might just suggest you use Logfire occasionally. So thank you very much. I think that there is a roaming mic and people can ask questions if they have any. There's a question here. There's a mic there.
Hey, thanks, Samuel. So I noticed in your code examples you use a lot of with method, like with logfire.span.
Yep.
Did you consider using decorator methods?
Yeah, I didn't show it here, but we have logfire.instrument that does exactly that. I should probably have had an example in here, but yeah, it's available. And again, it will automatically extract the arguments and the return type, show them as attributes without you doing anything. You can change the message, but by default, it's like calling whatever the function is. In fact, I think it looks pretty much like the auto tracing example, except that we also collect the arguments, which we don't by default for auto tracing for performance reasons here. So you see we're getting like calling dependents.get dependents. It'll look like that. You'll just have access to the attributes in the case you use logfire.instrument.
And then the other thing was obviously with logging, you sometimes end up with, you don't want certain sensitive information to end up in your logs. So how do you handle that? Yeah,
so we have a scrubbing mechanism that honestly right now is a little bit too aggressive in places. And we have basically a function you can call to decide whether or not something needs to be scrubbed. So we have a default version, we have finer grained control, and in future we will allow you to delete individual records or perhaps even individual attributes from within the UI when you see something get through. But yeah, we have something now. It's a very hard problem to solve fully because you can have the word authority does not mean that that it's auth and therefore it should completely block it out. But I think that's where we are now. But we'll relax it and we'll find specific cases where to change it.
Hi, thank you for that presentation. Huge fan of your work. Pydantic, we're heavily using that as well. And I can't just imagine how many log statements we're going to remove from our code base using this. So this is awesome stuff. I had two questions. One is, where is this UI hosted? And secondly, are we ever planning an integration with Datadog or some sort of other logging provider right now?
Yeah, good questions that I think lots of people will be wondering about. Before I get onto that, one thing I haven't included in this presentation is we also have integration with standard library logging, struct log, and log guru. So if you have an existing application that uses those things, you can basically get that data into Logfire with minimal amounts of work. The one thing that none of them really have is the equivalent of a span. So if you want the kind of context beyond what you get from your web framework in general, then you need to go and use logfire.span. But yeah, you don't need to immediately replace those statements. Your first question, integration with Datadog. As in today, because it's just OpenTelemetry and because Datadog will receive OpenTelemetry, you can go and set the URL you want to send data to Datadog. It won't look as pretty as it does in Logfire. Again, all of those pretty attributes, for example, those delivery Pydantic models, will just be a kind of sea of JSON, but you could get the data today. Was your question about us receiving data from Datadog or sending it to them?
Sending it to Datadog, and also where the UI, this UI that you presented here.
Yes, so Logfire, the application is closed source. It's obviously something we're going to charge for. It's free for now while we're in beta.
Sure.
I don't think we have any plans ever to open source the UI. We will have like enterprise hosting for bigger people, but like the plan is it's a service you sign up and use.
Gotcha. Thank you.
All right.
Hi. I had a question about some of the tracing. Like if we have a lot of microservices or a lot of fast API apps, or we maybe have 5 different ones, and then we have one API that's making all those calls, are we able to trace to the function calls in those API or in the separate apps? So does it trace down to the function level?
Yeah, if you manually instrument those functions or you turn on auto tracing, those I'm not on the right slide, but like in this case, getting there. this is exactly that, right? So this is 2 fast API apps.
Right.
Here we're in, again, it's unfortunate the colors are so similar, but we're in web UI. Then, in fact, this is auto tracing as well. So we're calling map JPEG. Then that is making, so this line here is coming from, you'll see here, HTTPX, auto instrumentation. That is then making a request, but it's also adding the OpenTelemetry header, which then means that this is effectively the top level fast API instrumentation of the tiling service. And you'll see here that's ASGI. Then we have function calling. Again, this is like enabled by auto tracing. And then you'll see down in here where we're doing the like map, whatever that is, get tile. And then inside that, we're doing another HTTPX request to OpenStreetMaps and then combining it together. But yeah, this is doing exactly that.
Gotcha. And there's no special configuration required. That's just like an auto magic.
That will auto magic work, provided that your web framework and your HTTP library are instrumented. But like I say, the HTTP library also injects this header.
Gotcha. Thank you. And a question about the alerts. Is there customization where we can like have a Python script execute on an alert?
Not yet. Okay. So effectively what we can do now is we can send it to Slack or we can send it to a webhook. So you could obviously use that webhook to do whatever you liked with it.
Gotcha.
We have no way right now of like running Python code within our platform to decide what to do. It's just SQL.
Gotcha. Thank you.
Yeah.
Gotcha. Appreciate it.
Cool. Was there a question here? Yeah. Do you want to?
When will you have the enterprise version ready for testing and with the prices?
That is a good question. I think it depends a bit how much interest there is in it and how much interest there is in other things. We have limited resources. I don't have an answer to that. If you're keen, though, come and talk to me. And basically, like bluntly, the more money that we might get from it, the quicker we'll do it. Is the simple truth.
Okay.
But like not before July. There's a question. Oh, yes, go ahead.
Do you have instrumentation of subprocesses? We tend to do one large application that calls a million different subprocesses, which calls additional subprocesses.
Yeah, so I think it's even when you call instrument, I can't remember, one of basically the only automatic thing we turn on is that we basically, use the same trick that OpenTelemetry, it's a similar trick to the trick OpenTelemetry uses to instrument HTTP requests across different things. We basically add another argument to multiprocessing and threads so that if you go across, in fact, I think this isn't, on this particular, I'm on the right, this is the example that keeps on giving. These, I can't remember, I think this here, where we stitch together the images, because it's quite heavy, it's actually done in a sub-process, but it's just within the same trace because it's already instrumented. I don't think we have, right now, we do collect the process ID, so that might show you where it changes, but we could definitely do a better job of signaling to you that things are changing. One of the related questions, which we should probably have touched on here, is task queuing, things like ARQ and Celery, etc. So there's already a Celery instrumentation for logfile for OpenTelemetry, so you should be able to see tasks going across into Celery jobs. There's a complexity there, which is that you don't actually want that job to be entirely nested within the parent span, because often that request has finished. It might have even finished before that job starts, but it'll definitely, in many cases, it will finish before your job starts. That's why you're doing stuff as jobs. And so OpenTelemetry has this concept of links. So you effectively, the correct thing to do is to set an OpenTelemetry link within the job so you can see which span started it, although it's not within it. And that's a work in progress, but we'll get there soon. And again, ARQ, my slightly unloved library that there's a long issue about me getting it going again. ARQ will also have obviously support for Logfire really soon.
So you mentioned that Logfire is based on OpenTelemetry, and OpenTelemetry already has a lot of extensions which can automatically instrument all the popular libraries. So you can install, for example, Django extension or FastAPI extension and instrument it basically with a couple of lines of code. you don't have to write any spans manually. It already can add all the useful metrics and traces. So could you reiterate what are the strong points of Logfire over those automatic extensions, and why should I switch? From what I understood, it makes a lot of sense if I use a lot of Pydantic. Is there anything else?
Yeah, I mean, I can go through the presentation again, but I think we've touched on quite a lot of things that we do different. I mean, what I would encourage you to do, and maybe we should have included this in this presentation, is go and write the 50 to somewhere between 10 and 50, maybe 80 lines of code that set up OpenTelemetry correctly. Then discover after a month of being in production that you did it slightly wrong, and so you've been dropping data occasionally. OpenTelemetry is not easy to get started with. It is not easy to configure, and if you have lots of different microservices, making sure all those examples are set up right, that's the biggest thing you get, is import it, get going. But then when you're using OpenTelemetry, that doesn't automatically give you a place to go and display that data, right? So there's open source library tools like Signoise, who are VC-backed companies who are trying to do this by saying they're building open source, and you can go and host that yourself. I would encourage you to go and try Signoise and compare it to Logfire, because I think you'll see the experience is quite significantly different. But we also have dedicated instrumentation. So OpenAI is the first one, but I think I was talking on Twitter the other day about doing Stripe next. I think we'll probably do Anthropic. I'm talking to the EdgeDB guys about doing an EdgeDB instrumentation, so we'll have a bunch of custom instrumentations. And then obviously the Logfire span, Logfire info methods are completely different. And then the biggest thing for me is the way that we can show attributes where we can transfer over OpenTelemetry richer data than OpenTelemetry can naively. So effectively, it's better than just JSON.loads indent2.
Yeah, okay, thank you. That's differs a bit from my experience, because those extensions, for example, I used one for FastAPI, can be configured to send the data to, say, Grafana, and it requires literally 2 lines of code. So I guess I'll come to you later to discuss it, because
okay, yeah.
I'm really interested how Logfire can make it even more easier. Okay, thank you.
Okay.
I just want to add, another point that Samuel did make is the querying interface. We put a lot of effort into making it full SQL, both for searching through UI, but also being able to run SQL against the data in our database. You can't do that unless you have a hosting,
Yeah.
Okay, I see. Thank you. I'm waiting for.
There's a question over here.
Yeah.
Hi. So you showed in SQL you can do aggregation, of course, and you talked a little bit about metrics, but I wanted to know, can you define metrics that are live derived from these spans, latency distributions and all?
Yeah. Yeah, so there are some questions about the performance of that, where we're working on basically some changes to our database to make very complex queries faster. But yes, you can go and do that now. So you could go and effectively write the SQL to basically subtract end timestamp minus start timestamp, and then start bucketing that, and you could then build a graph of that data. And in fact, we have that now on our default HTTP dashboard. Like I said, our dashboards are not as good as the live view yet, but they'll get there. But yes, you can effectively use metrics from traces, or you can use OpenTelemetry metrics to effectively send the raw number.
Yeah. Thank you.
Yeah, over here again. I maintain an open source library that is maintained through a paid web service, basically. I'm curious how much observability we would have into this open source library, which is effectively integrated as a third-party library, without adding all of the logging into the open source library itself. Is that where we would have to use or leverage the logging library, or is there some sort of exception handling or using auto trace and explicitly allowing it to trace a third-party library?
So there's a few different options. We have a library called Logfire NoOp, which basically has no dependencies and does nothing, but has the same API as Logfire. And the idea is that people who want to, I'm not expecting all libraries to do it, but there are people who want to, for example, Mirroscope AI want to be able to have literally Logfire calls within their open source library. So they're using, or they will use Logfire no-op. And then basically when you install Logfire, then you start seeing the data. Otherwise it just doesn't, does nothing. You could use logging, as you said, and then Logfire will pick that up. You won't get the nesting in the same way, but it will work. Or you could go and use OpenTelemetry directly. I think it's a pain to do, and you won't be able to do richer attributes. They won't like kind of just work out the box with Logfire, but that would be then a completely open source kind of vendor agnostic way of doing it.
I had one more question.
Yep.
So sometimes like in web applications, you end up with like, using caching, but you use it at the Nginx level. The request doesn't come all the way down to the application.
Yeah.
So I guess my question is, can you send like Nginx logs to the to Logfire, or even like supervisor logs or something?
If there's an existing OpenTelemetry integration, then we can receive that data. We don't have anything configured to do that otherwise right now. So not trivially, unless there's some existing OpenTelemetry tooling. But that's the glory of OpenTelemetry. There's a lot out there. But I think like to make one more point, we're not trying to be to do the thing that some observability companies have done, which is try to get all of the data from everyone, because that involves either basically charging an enormous amount of money or having a low margin. And we would rather basically get the stuff that is most useful. And so I used something a few years ago, Telegraph, I think was part of InfluxDB, where they were recording 647 metrics from Postgres every second. I showed that to my team, and they were like, I just really couldn't give a damn like about any of those numbers. How fast are my queries, and which ones is it? And that's why we built this, to try and give you the things you actually want, rather than just like log all the things. So if it's what you need, definitely, but I wouldn't say like getting data from every bit of your infra, off the shelf, off like immediately is necessarily always a good thing, right? Like the other thing we could do is we could say, oh, we'll collect all the data from GCP or AWS. That again is going to be an enormous amount of data, and I question where and when it's useful. Are we at time? I think we're near time. Wonderful. Thank you very much, everyone.